actually kind of enjoying this, to be honest. Maybe I'll switch to C. Today we're gonna do something that I've never done before. We're gonna be looking at some C code. Yes, you heard correctly, not C++. C. Specifically, this graphics engine with the Vulkan API written in pure C. A lot of you are probably going to be very happy, aren't you? Hi Cherno sir, I hope that you will review my code and roast, if necessary, my code. This guy knows how to get my attention. I'm a 13-year-old trying to experience the headache of creating a graphics engine in C with Vulkan and understand the Vulkan API more better. I mean, could you have described it better? I'm not sure. I know the code is simply a mess. Please don't say about it. Well, you know what? Last time we were tricked into thinking that the code was just the worst code ever and it was fine, so we'll be the judge of whether or not this code is a mess. I will fix it soon. I'm still working on it. For now, it just renders a triangle spinning due to some transformations. Pretty cutting edge stuff. The project uses makefile to build the project. If you don't want to use it, then run the batch file, sure. I know I didn't use any proper build system like Premake or Visual Studio 2022. I just don't use Visual Studio because it's very slow on my laptop. That's why I use VS Code. Please don't be upset for it. Well, you know what? VS Code is definitely a lot faster than Visual Studio, and if you are on pretty low-end hardware, then to be honest, like this is a fine choice, I think, especially because like the way that you can kind of deck out VS Code these days with all the extensions and stuff, you can get pretty decent C++ support like from it. In fact, if you're interested, I can make a video about how to set up VS Code for C++ because I think I've only got like Visual Studio videos on my channel, like setup stuff. So let me know if you want that. Also, if you get any sort of error with DLLs while running the program, then probably you don't have Vulkan 1 DLL on your machine. Simply download the Vulkan SDK runtime and attach a screenshot. Nice, this is very considerate. Oh, look at this, you're watching my videos. Yes, this is how you get me to review your code. Here's a link to the repository, which we'll take a look at in a minute. I hope you will review my code. Please, sir, you're the only one, I don't know where I got only from. You are the one who got me into OpenGL, and this is why now I am doing Vulkan. Please, sir, review my code. Thank you for your free time. Well, you know what? Since you asked so nicely and you used keywords like roast, I will take a look at this code. Now, because we are looking at an entire engine here and there might be a lot of code to get through, the full version of this code review will be available on patreon.com/thecherno, just at the $3 tier, along with my other exclusive videos. So let's have a look at the GitHub repository. This will be linked in the description below for those of you who want to follow along. So we're using a pretty modern version of C, C23 in fact. It can be built in only Windows using the batch file. GLFW for windowing and Vulkan as the graphics API, GCC to build the project, which is going to be quite a recent version of GCC, currently under development, and the debug mode is activated in the batch file. Okay, sure. So first and foremost, why make? Why use make files? CMake, please, or premake. But like, you know, you said you're not using a build system, but you kind of are because you're using make files, unless maybe some IDE is generating them for you, but you mentioned you're using VS Code. So I'm just not sure why this is a thing. Like writing all this out in make, just use CMake. Just use CMake. I know you're 13 and CMake might be a bit daunting. Make files are as well, to be honest. But I would, you know, use your age advantage and just get into it immediately, because trust me, by the time you're an adult, you will probably know everything. And I mean, I only started programming when I was like 16. So you've got enough time to learn CMake. Hopefully, I don't know if 3 years is enough. And while we are on the topic of learning, how could I not mention the sponsor of this video, Brilliant.org. For those of you who don't know, Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. For those of you who are not quite at the level of making your own Vulkan engine in C at the age of 13, I recommend you get your start on your programming journey using Brilliant's introductory computer science courses. What separates Brilliant.org from the rest of the competition, in my opinion, is their amazing way of teaching. It's really visual, engaging, and interactive. You won't just be sitting back and zoning out watching lectures or videos, you'll actually be engaging with the content, being quizzed about what they're teaching you to make sure that you're learning in the most effective way possible. And aside from their computer science courses, which eventually make their way into cool stuff like AI using Python, they've also got a huge collection of math courses which start at the very beginning and go up to more advanced topics such as calculus, which benefit so much from this visual, engaging way of teaching. And the best thing is they have a 30-day free trial that you can use to take a look at all of the courses on their platform completely for free. Just go to brilliant.org/thecherno, link will be in the description below, and that link will also get you 20% off a premium annual subscription if you go on to like it. Huge thank you to Brilliant.org, as always, for sponsoring this video. Okay, so taking a look at the code now on our computers here, I've cloned the repository. This is what we have. I've played around with it a little bit and I've got it to work with Visual Studio Code as well. And here we have main.c. So again, this is C. This is not C++. This is C. Let's begin by running this. So build.bat was what we were told to run, right? So I'm just gonna go ahead and open up a new terminal. This will open it up in this directory, and I'm just gonna call build.bat. And let's see what happens. So we actually get no feedback. Apparently, that's a bit annoying. And we just wait. I guess it's compiling. I don't know. I'm gonna try and call make in a minute, but it looks like it maybe worked. If we go back to the directory, we've got engine.exe, and yes, that was in fact built just then. So if I double click on this and we open it, we close it immediately. Let me try run it through this. Okay, so we get failed to find suitable memory type index. Yes, of course, this can't just work. Why would it work? It was sent to me for a code review. So let's just search for that. Failed to find suitable memory type index is happening over here. I think we can actually breakpoint this, and I should be able to just run this by just doing run start debugging, because I did hook up the VS Code stuff. So you can see, yes, we do end up here. And where's this coming from? So here's our call stack. So we're going in through the main function, obviously, engine initialize. This is also really good for reading code, because this is like a, you know, it's an engine. It's a little bit, it's got some code here, right? It's not the tiniest project ever. Sometimes I like going through code in this kind of fashion, like just seeing how it works and like what the call stack is, if I just put a breakpoint in like a critical function, for example, because that way you can obviously step through it, see what variables are, and you get a sense of like the calling structure and the actual structure of the program, because you can obviously see it all in the call stack. Sometimes it's a little bit difficult to just drill down to like these individual functions and, you know, find areas that are significant or that you care about. So that's another good way to read code. I think I made a video about how to read code in general. I'll have that linked up there as well. So it's trying to find a memory type index over here. And if type is invalid index, then we're getting this. So I guess let's step over this. So this works fine. So maybe let's put a breakpoint here and I'll just run to there. Okay, so here we go. Failed to find suitable memory type index. The type is 2. So invalid index is defined to 2. Really? Memory type 2 is an invalid index? So let's F11 into that and let's have a look at what's happening. We're going through this, we're checking it. Let's see if when we hit the return, and it returns 2, but 2 is an invalid index. So I think that's just wrong. Okay, buddy. So let's change this to like -1 or something that presumably is actually invalid instead of 2. What a weird thing to set that to. I'm being a bit roasty now because that's just annoying. Like, who sets invalid index to 2? And then I wonder if that will just magically fix it. It worked, you're welcome. How, okay, so I'm guessing this worked on your computer, maybe because the memory type that it pulled from the GPU, you have a different GPU probably, maybe it's Linux, whatever. It just happened to be maybe either 0 or 1 was the like appropriate index. And so you're like, oh, well, 0 and 1 are acceptable values. Let me just set it to like 2 as not an acceptable value. But you just have to remember that choosing like a value for invalid index, I would probably pick one or two things. Either -1, or you could set it to like FF, which is like the max value of a uint32t, which actually is that as well. If you cast that to like a uint32t, then you'll get the same result basically. That is acceptable, but like 2 is such an arbitrary thing to set it to. I mean, honestly, even 32 or like, I think, what was it? We saw over here, I think, that when we iterate through all this, we have VK max memory type. So, I mean, if you really wanted to, you could set it to that. I'm assuming I wouldn't do this, to be honest, but I'm just saying you could at least have set it to that because that index is going to be out of bounds. But again, that's only the case for max memory types. This is supposed to be presumably an invalid index that applies to your entire application, not just, you know, finding the right memory type or whatever. So therefore, again, something like -1 or whatever, I think would be a much better result. Now, this doesn't, in fact, return a uint32t, which again will mean that that -1 kind of becomes this. So if you feel safer, you could also probably set it to that. Again, I don't know if like feel safer is like the right thing to say, because either way, it's going to work out to be like just fine. But yeah, in this case, I think it would be also fine to set it to that. I think another thing that I'm guessing is available in C for you is something like uint32 max. Yeah, so you can see that's set to what I said, except there's just an unsigned thing to make sure it's not an int, it's a uint. So you could use this as well, standard int.h, that's obviously available in C. But yes, don't set it to 2, that's weird. Okay, so we have the running program, which is pretty exciting. Resizing does seem to work as well, which is nice. We have a spinning triangle. This is in fact, you know, primitive, but it's a good start. You gotta start somewhere. I think depending on the way the code is laid out, which again, so far looks pretty good. We'll take a deeper look in a minute, obviously. I think this might actually be a pretty decent 13-year-old engine, as in engine by a 13-year-old. So let's start at the beginning. Main.c. Ah, yes. C code. This is just something I did not expect to do when I woke up this morning. So we have engine. Okay, so this already is a little bit annoying to me just because these are the same word. Like, yes, it works, obviously. However, I would just have your types maybe be uppercase because that way it's like clear what's a type and what's a variable. I know that it's kind of a C thing, like people who write C code like snake case, as you can see, and also lowercase types, but I just think that I would make it uppercase. So what is engine? So engine is a struct. So we've got this beautiful type def struct. We've got the same name here as well. So a lot of people will change the name as well. So they have engine as like the little, whatever this is called. I don't actually even know what this is called, like little struct label or whatever. And then the actual kind of type made out of that, I guess. Because basically what you're doing is you're creating a struct called engine and this is it, but then you're type defing that to actually be something you can use. So a lot of people do tend to do like a little underscore T, but yeah, I'd probably just make it engine and then, you know, use engine like that. Anyway, I'd probably use C++ as well. We'll get into that in a minute, but whatever. Same with window and renderer, you know, I'd make them uppercase. Now, what I like already is that, and this is like the beauty of C, right? Like I prefer C++. I like C++. I think it's a great language. And more importantly, I think that everything you see here could obviously be done exactly the same way in C++. So there's no limitation really to using C++. The problem that I think a lot of people have with C++ is the fact that you can get carried away because there are so many features and it's almost like using a linter maybe for a language like JavaScript. It keeps things a little bit more contained, a little bit more precise, and it stops you from running away, or by using like a type system for JavaScript as well, like TypeScript or whatever else. I see the value of that. However, I think that it's possibly unfair to blame the language for poor programming decisions that are made by the programmer, because C++ is a very flexible language and a lot of people will argue that that's a downside. But I think that how can that be a downside? Like, it's a downside if you use it poorly, but it's a huge upside if you know what you're doing, because in a lot of cases you can actually, you know, in my opinion, obviously this is all my opinion, welcome to my channel, in my opinion, write code in a way that is just, I guess, better in most ways, like specifically for the programmer, I mean, because like this is a really good example of where maybe using a class for engine would essentially do the same thing that you're doing here, but make the code a little bit cleaner. It's really not like a big deal. So what I'm talking about is if we had a class here, which obviously I can't do, we're in C, but if we had like this struct called engine, pretend this is C++, this part, and then, you know, we could have everything that we needed to in here. Let's just say it was private and we had, I'm running C++ code in C, I'm gonna get canceled for this. And we had like, you know, we had window, we had, I think renderer was another thing that was in here. And then, you know, inside engine or whatever, we might have a constructor. We'll just say we don't because this doesn't really do anything in a constructor because there is no constructor. But instead there's initialize. You know, you could still have that function called initialize. You could still have, you know, run and shut down, for example. So we're doing the same thing. But what we've done is we've just managed to combine functions with data like this, because these functions, it's almost like an entity component system in a way, right? So we have the components here, which are the data, and then we have the systems here, which act on the data. And they're basically grouped together, which is a design that I really like. I think it's good. Now, note, there's no like silly inheritance going on here. I'm not like abusing, I'm not using OOP in like the bad way that everyone basically hates. I'm just organizing my code a little bit better. And then so what that would do is you'd have this like alternative engine, right? Where again, you would just call engine.initialize. And the cool thing is you basically like, you don't need to pass in that engine because that happens automatically. So these functions basically kind of contain like a pointer to engine, which is kind of called this, right? Without the underscore. So that obviously if you're inside these functions, you can actually use, you know, this to like reference members or whatever, but you don't need to because it's done for you automatically, like by the compiler. But this happens automatically, so you're just kind of reducing having to, I guess, call, you know, having to basically provide a parameter like this in every single function call because you want access to the data that is stored within the struct. You're getting that automatically by basically putting it out here. And since there are also no namespaces and also function names such as initialize, run, and shut down, you know, very, very generic, and every single system in this engine, in this project, could have functions named exactly that, you need to prefix everything with engine underscore, which you can see is kind of what's going on here with the engine dot. It's just kind of done automatically. And then you get rid of that. And then I think it's a little bit more safe. Another thing here that might be a benefit is obviously RAII, which I know a lot of people hate, and this will be annoying, but initialize and shutdown could be combined into the constructor and destructor of engine, which kind of just means that the only function you need here is run, in a way. Right? So if we put this into a scope, and again, I'm not necessarily arguing that you should switch from C to C++, and this is the correct way to do things. We're just talking about this, all right? So just relax, just take a chill pill. I can feel some tension coming from the audience right now, and I'd like you to stop. And so engine, and engine.run, like inside the scope, when the scope finishes execution, we'll kind of run all of this, right? And obviously you can see how we can achieve much more with much less code, right? So I think in that sense, again, of course you could argue that both ways. Oh, but it's less clear because I don't know there's initializing and shutting down. Sure. But these kinds of alternatives, again, without getting too carried away, there's no templates here. There's no inheritance. There's no polymorphism. This is just C++, but it's a very basic version of it that can, I feel, enhance your code. And that's why I tend to just use C++, because I think that if you do that more or less properly, then of course you can just have that extra flexibility to really craft the code in a way that, again, if you know what you're doing, I think will be superior. Now, bringing us to the topic of if you know what you're doing, because I think that C, since it is limiting, does in fact force you to think about things a lot more. And I think we're seeing that over here. If this was C++ code, especially if it was taught in an object-oriented kind of sense, right? We wouldn't be seeing engine, and then passing engine everywhere, and then the engine struct itself is also gonna have window. No. Do you know what we would be seeing? We would be seeing engine pointer engine equals new engine, and then inside the engine class or struct or whatever, we'd probably be seeing pointers, and we'd be seeing the new keyword everywhere, and that is objectively inferior to the setup that we have going on over here. So I think that because C doesn't have the new keyword, even though we could have achieved the same thing by using malloc, obviously that's almost like it's not your first instinct, because that's almost like, oh, well, who wants to call a weird function called malloc and then have to pass in the size of the engine? And then have to use pointers and then have to call free, at the end of that. That's not something that I feel comes as naturally as obviously just this. I think because of that, you could definitely argue that C is enforcing just a better way of programming out of the box. And I think that's why maybe it is good for beginners. But again, if C++ was taught in less of an object-oriented sense, because I was taught C++ in university in my second semester, first year. In the first semester, we started with Pascal for some reason, and then halfway through, 6 weeks later, we switched to C. I don't know why they decided to do these two languages. They should have probably just started with C and then done 12 weeks of C. But anyway, so we learned C first. But then the next semester, we had this subject called object-oriented programming. Which of course was mandatory. And that's where 3 languages were introduced: C++, Java, and C#. And you basically had to pick one. I think in the first few weeks, they did everything in they showed everything for all 3 languages, and then after that you were basically on your own. But I think the university chose to stick to C#, which was a good choice. I chose C++ as my language just because I was more interested in it, and I already knew Java decently well and C# similar, so I wanted to learn something new basically, so I chose C++. That was all the way back in 2013. But here's the thing, the way that C++ was taught, obviously because the subject, the unit of study, was called object-oriented programming, it was taught being everything is an object, new keyword, polymorphism, inheritance, virtual functions, building these class hierarchies. It was taught in that sense, which of course is horrific because I don't know. I mean, if Cherno University was a thing, let's just say things would be different. But I do want to mention that since it seems, well, in my experience, but also in a lot of other experiences I've heard as well, C++ is taught in that fashion. Teaching C is probably the better thing to do. And learning C is probably the better thing to do, because I feel like it teaches you actual programming. As in, let's make the computer do this in the simplest way possible. Let's not decorate things. Let's not create this abstract mind map of how things should work in a human sense. And then the computer is gonna have to do so much more to kind of deal with our clouded mind crap. I think it's very easy to get pulled into that trap of trying to make things work for you. Whereas I think the priority should be making things work for the computer. Okay, anyway, let's get back to the code, shall we? So yes, good to see that these are all kind of created on the stack and not malloc or whatever. Really nice. And then we also have, this is also beautiful. I'm actually kind of enjoying this, to be honest. Maybe I'll switch to C. This is not like in global space. This is all very well contained inside this stack. Right? This is what I love as well. This is not like some global object that is over here, right? And I think that's the beauty as well of C, is that it's not even the language itself, because of course this could be a global variable. Of course this could be like a static global as well. Of course it could be a pointer. Of course we could have dressed it up like this, just like we could have in C++. No issues there whatsoever. However, it's almost like the language has like a bit of a code. Maybe I'm just looking at decent C code here, like good C code here, as opposed to like bad C code. If people have bad C code, maybe they can send that to me and I'll have a different view. But because I'm looking at this code here and I do see this a lot in C, we create like a struct instance, like this kind of object, I want to say. It's not really. We create this like variable here that is obviously these things in like as tight of a scope as possible, and then we just pass it around as parameters. That is just the way that C works. Like people just do this in C a lot. And obviously it's really good because you can see here that if we dig a little bit deeper and we take a look at what the memory is actually doing, we're in stack space here, right? We're allocating a bit of stack storage to contain whatever engine contains. Then we're calling into a function which pushes more stuff onto the stack with a pointer to memory that's already on the stack, right? So this stuff is really hot. It's really nice on the CPU cache, right? It's there. It's ready for us to use. As opposed to if this had been a pointer or if we had made it a global or whatever, then suddenly we'd be drilling into like engine initialize. And when we start accessing these things, we're over here and we're trying to pull stuff from, you know, like, let's just say over here, I'm just trying to draw not on the face cam. And then maybe like, again, if that had also contained pointers or some other global memory, like that could be somewhere over here and we've got this whole net. Whereas what we're doing is everything is on the stack and we push something else onto the stack, which is like this function, and it's referencing stuff that is already on the stack and everything's taking place here. Nothing is reaching into here. And that's beautiful. That is exactly what you want to be doing. And it seems that C really encourages that. Because again, in my experience, I've just seen this structure, this way of programming happen a lot in C. And people are surprised. They're like, oh yeah, C is faster than C++. Like, you know, this is written in C, therefore it's so fast and everything just works. It's because there's a lot of bad C++ code out there. It's because there's just a lot of junk out there that's making everything else look bad. It's kind of like games made in Unity. Anyone can make a game in Unity. Not saying C++ is easier than C necessarily, but anyway, I think it's probably more popular. Anyone can make a game in Unity, which is why it's almost like it's brought down the average level of quality, and now people kind of look at a game that's made in Unity and that's almost synonymous with junk because the bar is so low and people are just doing little like asset flips or whatever and they're just releasing them on Steam and suddenly the games are just bad and people think that's what Unity is. Unity has a lot of problems, but you can make good games in Unity just like you can write fast code in C++, right? The language is almost not the issue here, but it seems like C lends itself more to perhaps either more experienced programmers or just naturally lends its way to writing more correct code. And that statement seems true based on my like real world experience. Okay, anyway, let's stop talking about C and C++ and stuff and move on with the code. So initializing all these variables. That's another thing that I think is mildly annoying. The fact that like, obviously we're not initializing any variables. Like we don't have default values for these variables here, whereas we could have, and that does make things a little bit dangerous potentially. Obviously like something that is common to do is just to run a mem set of like, you know, into like say this structure and then just set it to 0. So you can just do engine window, for example. We can grab that value 0 and then size of the type. So that's just a quick way to clear everything and initialize it to 0. 0 is not always what you want potentially, but it is something that we can do, right? To just set the memory basically to be 0. Not necessarily required, obviously. You know, if you go through and you set every variable properly, then you'll get that. But that's almost like the C equivalent instead of in C++, like we would just have default values for variables, which I think is good. I think that's nice. So one thing I quite like about this is the fact that this takes into account max frames in flight, right? So it's set to 2, which is pretty standard. You know, NVIDIA GPUs tend to support 3, so it's obviously very easy to configure, but I wouldn't have this in the first place be a define. I'd have this be an engine configuration thing. In general, you want to avoid defines, right? Maybe something like invalid index is fine, but generally I would avoid defines, and instead I would try to have variables. And specifically for something like this, because this shouldn't be a compile time constant, what I would do is I would instead, maybe even in the renderer or in the engine, I'd have like a renderer specification that you could take in where you could have a max frames in flight that you could set manually to 2 or 3, for example, but then when the swap chain gets created, it can actually tell you how many like swap chain images you have, basically, and then therefore how many frames in flight you can possibly have, right? Assuming you're rendering to the swap chain. So therefore you could kind of set it to 3, but then obviously cap it to 2 if you're maybe on a graphics card that only supports 2 frames in flight. But the fact that obviously you have 4 thought into this is good. Yeah, I mean, look, this is actually kind of interesting because I haven't looked at the C code in so long. I may have looked at the C project sometime in the past for the code review series, but I definitely didn't focus on the C aspect of it as much as I am today. So this has been quite enlightening. So yes, max frames in flight is good. Let me quickly explain that for those of you who don't know what that means. Basically, we potentially have more than one swap chain image that we can render to, right? Usually we use double or triple buffering for our window, which means that we can kind of be drawing into one image while we're displaying the other one on our screen. Now, here's where the advantage comes. If you account for that in your code and you can have this like max frames in flight situation or whatever, what that means is that because what happens is that generally on the CPU side, you're doing all of the CPU stuff, you're recording all of your commands, and then you're giving it over to the GPU to actually execute that command buffer and therefore most likely draw like pixels to a frame buffer, for example. Drawing pixels to a frame buffer involves obviously like running through the whole graphics pipeline and like executing your shaders and stuff like that. That takes time. And depending on how much you've recorded in there, it could be like, you know, in a game, it could be like the frames worth of work potentially. Games can be a little bit more complicated than that, but bear with me. Let's just say it's a simple game. Like it's recorded all of its stuff into a single command buffer. And then now it could take like, I don't know, 10 milliseconds or whatever to get through that code on the GPU. So this is now the GPU marked with NVIDIA green. This is the GPU taking 10 milliseconds. Now, usually what would happen potentially in something like OpenGL, we'd call something like GL flush, or like when we do GL swap buffers, maybe it would call flush like maybe internally. And basically the CPU would just sit here waiting for 10 milliseconds before you progress to your next frame. And then you record the CPU stuff, which could take, let's just say this takes 2 milliseconds to do all the CPU stuff and record the commands. And then execution on the GPU, let's just say, takes 10 milliseconds. So you're basically kind of paying 12 milliseconds in a way. I should pick a higher number than 2, but whatever. You're basically that's how long a frame takes because you're GPU bound here and you're waiting for the GPU to finish. You can't do anything on the CPU. But if you take into account this frames in flight situation and you've got multiple buffers to write to, then what you can actually start doing is you can grab the next swap chain image, start recording all of your commands for that image instead, potentially. Again, this is a simplification, but whatever. And that might take another, let's just say 2 milliseconds. I should have used, so CPU will be blue. So we've got 2 milliseconds over here for this as well, while the GPU is doing this. And then you can like full on like submit it and everything, because even if it hasn't finished with this, it's got a different target to read from / write to, because like we have more stuff here. Like for example, the uniform buffer object that contains maybe I don't know what this contains. Maybe it's the triangle positions in this case, but it might be something like your camera. You can actually stream data in from the CPU to this while you're accessing another version of that in this. So that's the other problem, right? If you just have one camera buffer, then that means that if that's necessary for rendering, then the GPU needs to be able to read that buffer. So if you try write to it, because you're not waiting for the GPU to finish, you're progressing with your next CPU frame, then you will overwrite memory that's currently being accessed by the GPU. Vulkan will yell at you for that. You don't want to do that. So instead you create multiple buffers so that you can kind of alternate almost. So if your GPU is currently rendering and it's accessing one buffer, you can write in your next frame's worth of camera data into the other buffer. And then obviously that will be the one that's used by the GPU for the other frame. And so what that does is that moves this 2 milliseconds to happen concurrently with the GPU. So the CPU's 2 milliseconds for the next frame is happening while the GPU is rendering the current frame. And all of this is possible because you account for it and you have this like max frames in flight situation where you can have more than one frame in flight, meaning you can have more than one frame that's currently being worked on by either the CPU or the GPU. Even though, yes, in most cases, your GPU would probably only have one graphics queue, and we're not going to talk about compute or anything here. So therefore, you are kind of rendering frames one at a time on the GPU. The CPU can just kind of run ahead a little bit. Okay, did not expect that to be that in-depth, but I just liked the fact that this is being taken into account because a lot of people in general don't take this into account at all. And especially not 13-year-olds, so well done. Yeah, like look, for like a beginner kind of Vulkan application, this looks really good. Code looks really neat. Everything seems to execute well. It's really simple, really easy to follow. Good use of C, I think. Like, I'm not a C programmer, but I like what I see. And I feel like there's a lot of lessons here to learn for you guys watching probably, and for me as well. Even if you are a C++ programmer, right? Like there's lots that you could probably take from this, because I think this is just like it lays stuff out really well. It is simple. It's easy to follow. It avoids complexity in terms of like memory access and variables and stuff like that. Everything is just super smooth. So honestly, I think I'm going to say this is one of the best projects I've ever looked at in this code review series. You get a star. You got a star. Really good work. And if you really are 13 years old, then this is excellent. This is just really good. I mean, obviously a lot of this could be copied and pasted from places, but look, getting this up and running, getting this working as a 13-year-old, you know, and if you do actually understand this, like the way the program is structured and all that stuff, I think, honestly, well done. What did you guys think of this code? Do you agree with me? For those of you who might be more experienced with C specifically, do you see anything wrong here? Let me know in the comments below. Now, if you guys want to send in your code for me to take a look at, then email it to chernoreview@gmail.com. That email address and some instructions will be in the description below. Will you be next to win the star? Let's find out. I'll see you guys next time. Goodbye.